welcome back to the world of quantum computing. In the previous lecture, we studied about the vector spaces, what are addition vector, and what are the four properties of addition vector. We'll just quickly recall it. There are four properties. One is associativity of addition, and the second property is if there is a zero vector, then it should satisfy in such a way that u plus 0 equal to 0 plus u should be equal to u. If this condition is satisfied, then it is also a vector. And third property is for all vector u belongs to vector space V, there should be an existing additive inverse of u. And property 4 is the addition of vectors is commutative. Okay, we'll get back to the scalar multiplication. Scalar multiplication is the multiplication of a vector by a scalar results in another vector that is also there in the vector space V. Okay, the first property is distributive of scalar multiplication over vector addition. By reading only, we understood that we are going to multiply a scalar with the addition of vectors. That means let's take our scalar or consider our scalar is alpha and vector addition is u plus v vectors. Okay, it will result in again two vectors only. Then the second property, scalar multiplication over scalar addition. This means the multiplication of a scalar is being done on scalar addition only. That means we are having two scalar values which are multiplied with a scalar again, which result in alpha u plus beta u. Okay, and the third property is associativity of scalar multiplication. Okay, that means alpha beta into u is equal to alpha into beta of u. This is our third property. Last and final, identity scalar. That means identity means we all know it is 1. So identity of scalar 1 should be always a vector u again. Okay. That's it for the day. In next lecture, we'll focus on inner product in quantum computing, and later we'll proceed with linear combination of vectors and so on. That's all for the day. Thanks for watching. See you guys in next video.